Have you ever really stopped to think about how an entire ecosystem gets built? You know, a whole forest or a lake or even the ocean. Where does all that life actually come from? Well, that's what we're going to do today. We're going to build one from the ground up, starting with nothing more than a single beam of light.
So here's our game plan. First, we're going to find our ultimate power source. Then, we'll see how that energy travels through a super intricate food web. After that, we'll dig into the rules of the game that govern the whole system, explore its incredible recycling program, and finally, figure out how you can actually tell if an ecosystem is healthy.
So let's start with the biggest question of them all. Before we even get to who eats who, where does the energy for, well, everything even come from in the first place?
And that brings us right to Section 1, the ultimate power source. This is all about how pure energy from space gets turned into the fuel for life itself.
Yep, you guessed it. It all starts with the sun. It is the massive, nonstop engine for our planet. Just about every bit of food energy that has ever existed on Earth can be traced right back to that star, 93 million miles away.
So how does that sunlight get captured? It's all thanks to these amazing organisms we call producers. Think plants, algae. They perform this incredible trick. It's basically magic, called photosynthesis. They take sunlight, carbon dioxide from the air, and water, and they turn it all into energy-rich sugars. They literally make their own food, and in doing so, they form the foundation for pretty much all other life.
Okay, so the producers have locked in all this solar power, but how does that energy get passed around? Well, that leads us to Section 2, life's intricate food web. And this is where consumers step onto the scene. See, unlike producers, consumers can't make their own food. So to get the energy they need to live and grow, they've got to eat other organisms. It doesn't matter if it's a rabbit eating grass or a lion eating a zebra, they're all consumers.
But what happens when all these plants and animals die? All that energy and all those valuable nutrients would just be locked up, right? Not if the decomposers have anything to say about it. These are the unsung heroes of the ecosystem. We're talking fungi, bacteria, and they act like a massive recycling plant, breaking everything down and returning the raw materials back to the soil so the producers can use them all over again.
Now, the simplest way we learn about this in school is the food chain. It's a nice, clean, straight line. Energy from the grass goes to the rabbit, and energy from the rabbit goes to the fox. Simple, right?
But of course, nature is rarely that neat and tidy. The reality looks a whole lot more like a messy, tangled food web. A fox doesn't just eat rabbits. It might eat mice too. But hawks also eat rabbits and mice, and the mice are eating seeds, not grass. The point is, it's not a simple chain. It's this incredibly complex web of connections.
So, if it's this big, complicated web, what stops one animal from just taking over everything? What keeps it all in some kind of balance? That's what we're diving into in Section 3, the rules of the game. These are the invisible forces that shape the whole system.
You know, when you boil it down, interactions between species come down to two basic strategies. You either compete or you cooperate. Competition is that constant struggle. It's when two organisms, like our fox and hawk, both need the same limited resource. But cooperation is the exact opposite. It's when organisms actually work together, sometimes so closely that they literally can't survive without each other.
These really close relationships are called symbiosis, and they come in a few different flavors. On one end, you have parasitism, which is a total win-lose situation. Think of a tick on a deer. The tick wins, the deer loses. But then you have mutualism, which is a win-win. A classic example is the bacteria in a termite's gut. The bacteria gets a safe home, and in return, it digests the wood for the termite. Everybody's happy.
But it's not just about relationships. The environment itself plays a huge role. We have what's called a limiting factor, which is basically anything that puts a cap on how big a population can get. It's the natural ceiling that keeps things in check.
And a lot of these factors aren't even living things. We call them abiotic. Just think about it. You can't have a forest without enough sunlight and water. You can't have fish without enough oxygen. A shortage of any one of these can stop a population in its tracks, no matter how much food is around.
And this table just shows so perfectly how everything is connected. Check out this cascade effect. A single change, something as simple as less rainfall, starts a domino effect. Less rain means less grass. Less grass means fewer rabbits can survive. And fewer rabbits means fewer foxes. That one little change sends ripples through the entire food web.
This all leads to this really cool idea in our fourth section, the never-ending cycle.
See, while energy flows through an ecosystem, kind of like a one-way street, the actual physical stuff, the atoms that make up everything, gets used over and over and over again.
To see what I mean, let's just follow a single carbon atom on its journey. Okay, so it's floating around as a gas in the atmosphere. A plant sucks it in and uses it to build the leaf. Then a rabbit comes along and eats that leaf, so now the atom is part of the rabbit. The rabbit breathes out, and some carbon goes back to the air. Eventually, the rabbit dies, and our decomposer friends break it down, returning the rest of the carbon to the soil, where it's ready for a new plant to pick it up and start the whole cycle again. It is the ultimate recycling program.
And it's not just carbon. The water you're drinking right now has been on a journey for billions of years, cycling between oceans, clouds, rivers, and living things. Yeah, including dinosaurs. The matter is never lost, it just gets rearranged.
All right, we've done it. We've built our system. We have an energy source, a food web, a set of rules, and recycling. So for our final section, let's put it all together. What does a healthy, strong ecosystem actually look like? The single most important word here is biodiversity. And this isn't just about having lots of animals. It's about having a huge variety of different kinds of life, all playing different roles. It's like a good investment portfolio. You don't put all your money in one stock. The more diverse an ecosystem is, the more stable and resilient it is. It's a direct measure of its health.
And this is so important to understand. A healthy ecosystem isn't static. It's not frozen in time. It is always changing. Populations go up, they go down, but in a stable system, those changes happen in a predictable rhythm. It's not chaos. It's more like a dynamic dance. This quote from the NRC framework really just sums the whole thing up. It says, disruptions to any physical or biological component of an ecosystem can lead to shifts in all of its populations. Basically, because everything is so tightly connected, if you mess with one part, the entire web feels the tremor.
And that leaves us with one last, really big question to think about. We've seen how this whole beautiful, complicated system is woven together by energy and matter, all governed by these invisible rules. So in this incredibly delicate web, what happens when just one thread gets pulled?